So we have these two simultaneous equations, and we want to find the values of x and y. We're going to start off with the first one, which is 4x plus 4y equals 44, and we're going to call this equation 1, and this one is equation 2. So we're going to take these two equations and we are going to convert them into a matrix equation. So we're going to have one matrix multiplied by another matrix equals another matrix. This first matrix, this will have the coefficients of the algebraic terms. What does that mean? You see here we have a 4x, we're going to pull the number from it, so we're going to get 4. This has a 4y, we're going to get another 4, 3x, we're going to pull the 3, and 2y, we're going to pull the 2. So this first matrix, we're going to call this matrix matrix A. This will have all of the numbered part of the algebraic term, or what we like to call it the coefficient. This second matrix that is multiplying matrix A, we're going to call this matrix X, and this will have the variables, the actual letters, if you want to call it that, but variables is the term, X and Y, what we're trying to find. And those two matrices, when you multiply them, we're going to get matrix B, which is 44 and 28, what they're equal to. So now that we've converted these two equations into a matrix equation, we have to find the determinant of A, and that will give us the inverse. So let's start off by doing that. So you're going to multiply the top left by the bottom right, so 4 by 2. And then from that, you're going to subtract the top right and the bottom left, so 4 by 3. Alright, so 4 2s are 8, and 4 3s are 12, so that's going to give you negative 4. Once you have that, you can find your inverse of A. So that'll be inverse of A is equals to 1 over your determinant, which was negative 4. And you're going to multiply that by what we like to call the adjoint. So you see how we multiplied 4 by 2 and 4 by 3? You're going to use those same numbers, but in different ways. So the 4 multiplied by 2, they're going to switch positions. So the 2 will go up here, and the 4 will come down. And the 4 by 3, they're going to stay in the same place, but they're going to change signs. So they're both positive now, but the 4 becomes negative, and the 3 becomes negative. And with that being said, we have our inverse. Now we can find x and y. So we can say now that x and y is equal to our inverse, which is 1 over negative 4, 2, negative 4, negative 3, 4, multiplied by our matrix B, which is 44, 28. This is our inverse, this is our matrix B, and this is obviously x. So let's multiply. Now remember, when you're multiplying fractions, you are going rows by columns. So this row is going to multiply this column, and then this row will multiply this column again. So let's see how that goes. So 2 by 44, put them in brackets, plus negative 4 by 28. This is going to be the first row. Second row will be negative 3 now, by 44 plus 4 by 28. And this is this bottom row here, multiplying the column. Alright, so let's see what we get. 2 by 44, that will give you 88. Yeah. And then plus negative 4 by 28. That's going to give you negative 112. 3 by 44, that should give you negative 132, because the 3 is negative, plus 4 by 28, again, is 112. And now we can simplify this a bit. So 88, this plus minus becomes a minus. So it's going to be 88 minus 112, and that will give you negative 24. And negative 132 minus 112, and that's going to give you, sorry, negative 132 plus 112, and that's going to give you negative 20. So now we have this fraction on the outside, negative a quarter, and the short way of doing this is just to divide what's on the inside by the denominator, which is negative 4, and you are going to get that. This looks like a 9, and xy is equals to 6 and 5. So therefore x is 6 and y is 5. Alright, let's look at another one. So we have here 2x minus 2y will give us an 8, and 4x minus 3y will give us 15. Equation 1, equation 2. Okay, alright, so we are going to start by again converting these two equations into one matrix equation. So you have your A matrix multiplied by your X matrix to give you your B matrix. Your A matrix is all the coefficients or the numbered parts of the algebraic term. So you have 2x, you're going to get a 2. You have negative 2y or minus 2y, you're going to get that negative 2. You have 4x, that's going to give you a 4. You have negative 3y, that's going to give you a negative 3. Again, our x matrix doesn't change. It's going to be x and y, and b will be what these are equal to, 8 and 15. From that, you're going to find the inverse of a by first finding what we know as the determinant. So you're going to multiply diagonally again. So 2 multiplied by negative 3 minus negative 2 multiplied by 4. 2 by negative 3 is negative 6, and negative 2 by 4 is negative 8. And these two negative signs combine to give you a plus sign, so you're going to have negative 6 plus 8, which is equals to 2. So our inverse for a is going to be 1 over our determinant, which is 2, and that's going to multiply. Again, we're going to use the same numbers, but we're going to use them in a different way. So the 2 and the negative 3 will switch positions. So negative 3 goes up here and 2 comes down, and then the negative 2 and 4 will switch signs. So the negative 2 becomes a positive 2, and the positive 4 becomes a negative 4. Alright, then we are going to take our x and y and find it by multiplying our inverse, negative 3, negative 4 to 2, by our b, which is 8. I don't need that. 8 and 15. Alright, so let's see how this goes. Again, we've ignored the fraction on the outside, and we just focus what's on the inside. So we're going again rows. This is the first row. This is the second row, and this is the column. So we're going rows by columns. Yeah. So it's going to be negative 3 multiplied by 8 plus 2 multiplied by 15. And then on the bottom rows, negative 4 multiplied by 8 plus 2 multiplied by 15. So you're going to get negative 3 by 8 is negative 24, plus 2 15s are 30, and negative 4 by 8 is negative 32, plus 2 15s are 30. And then you're going to work that out. So negative 24 plus 30 is 6, and negative 32 plus 30 is 2. It's negative 2. Yeah. So now we just divide both x and y, both 6 and 2, negative 2 by 2. So you're going to get, mistake. So you're going to get negative 2 divided by 2 on the bottom. And your answer is going to be 3 and negative 1. So therefore x is 3, and y is negative 1. Now, this is essentially how you do it. So what we do is that we take the two equations, we convert them into one matrix equation right here, and then we we find the determinant from there, which is 2. And then we find the inverse using our determinant, and then we simply multiply the inverse, which is this, by our b, which is what we have initially. And we work it down, and then the fraction on the outside, the denominator divides the numbers on the inside, and that gives us our answer. As you can see, it's a lot of work in, and one might ask, why even attempt it if one mistake can, mess up the whole thing. But there is a way to check it to make sure that your two answers, what you get out at the end, for instance, this x equals 3, y equals negative 1, if it is correct. And what we can do is we can substitute these two variables into any of these equations above. So for instance, let's see how this goes. So we're going to use equation 1. Equation 1 is 2x minus 2y equals 8. Now we just worked out that our x is 3 and our y is negative 1. So instead of writing 2x minus 2y, we can write 2 by 3 and minus 2 by negative 1 equals 8. Now to test to make sure that 3 and negative 1 are both correct, what we have to do is work on this left hand side. And if we get it equals to 8, then we are good to go. So let's see. 2 3s are 6 minus 2 by negative 1 is negative 2. And the negative and the negative together, these signs together, give you a positive sign. So you can have 6 plus 2, which is equals to 8. So because that when you work this out, you get an 8, which is what is equals to, then you know, well, it's correct. So before a shadow of a doubt, this second one is indeed correct. If you had a look at this first one, where we got x equals 6 and y equals 5, we can pull again any of these equations. So let's pull the second one, which is this 3x plus 2y equals 28. So we have 3x plus 2y equals 28. But we know that x is 6 and y is equals to, 5. So instead of writing 3x plus 2y equals 26, we can write 3 times 6 plus 2 times 5 equals 28. And if we work this out and we get out 28, then we're good to go. Okay, so 3 6s are 18, and 2 5s are 10, and 18 plus 10 is 28. So that means that this answer, x equals 6 and y equals 5, is correct. And that is how we do simultaneous equations. We solve them using matrices. And you can always check your answer to make sure your work is correct.